Fuck it, man. I'm just gonna do the math theory without any paper, like, you know, visuals. It'll be like this. This does. Okay. Okay, so this is like, I guess what do you call it? Theory of math. Like they talk about that theory. Number theory, theory of math. The number theory. Oh my god, I got that. And it's like nothing. I mean, it's like simple. Okay, so this theory, like, it's symbols on a paper. That's what the whole theory is. It's that piece of paper, you know, and these symbols. And we'll even say, you know, when you have to be like, what's the control? Like, you know, when you find a dinosaur specimen, it's like that's the type specimen. So like the actual argument. And then you get into, oh, what is logic, this, that. You know, it's this piece of paper, it's a piece of paper, this piece of paper. I got this pencil, I did this. It's like that. Like that's the theory, okay? And you know, you have symbols, things you're gonna write on the paper, symbols, you declare them, and it can be manipulated certain ways. And it's also, it's gonna be, you can put it in front of a mirror and you can read it backward. You know, either way. So the divided by sign, you know, would have an arrow on it. So like when you put it in a mirror, you know which way it goes, okay? So check it out. We started about thinking about regular math equation, algebra equation or something like that. And what we got the equals, and we got the numbers, and maybe we got some multiplication, division, something like that. I'm going to get rid of everything. Nothing except for the division sign. There's no multiplication sign because that's divided by. That's just, you know, is multiplying, okay? And divided by is directional, so that also already gets rid of all your dividing by zero problems. Like, why? I can multiply by zero, but I can't divide by zero. Well, you can, you know, it's directional. You can't actually multiply by zero in a certain way. You can't say, put 6 eggs in 0 baskets. You can't do that, like, because it's divided by. And you have to put divided by 0 to do it. And it, of course, won't be a 0. That's just like a nothing on the paper there. Like, that'll be the same thing. And so what we have is, you know, you don't have to have a symbol for 0. It's just blank paper. And you have brackets, which you already presume brackets for the math. So it's like, oh, like if I look at this equation and you know, there's nothing within an inch of it or something, so let's presume brackets. So you already have that. So you're not really adding something by putting brackets. You know, or you don't go looking off the edge of the page and start looking on the wall for more symbols or something, like, you know, you got a presumed bracket, stuff like that. And for this thing, we just have brackets. You have a bracket, and maybe brackets that can go inside brackets, and maybe some kind of rule like that, or, you know, however that's going to work. And that's not already have brackets with any kind of math, because otherwise you're looking for the rest of the equation. You're looking over on the wall or something, right? It's a presumed bracket. And so, okay, so, and so we'll start with just regular numbers, but then I'm going to replace them. I'm going to replace 1 with, just, of course, what is it going to be? It's not divided by not. It's just the, in a bracket. It's going to be the divided by symbol itself in a bracket. And that's 1. And it works. Okay. Now, okay, so if you have, so all the numbers, like 1, 2, 3, whatever the hell, it's like you don't have plus. You don't have the plus sign. It's just like plus is already there. If you put like number 1, that's just plus 1. Because on your paper, within the brackets, if it's brackets, you got what, like this bracket, and it's got nothing on it. You know, it's nothing equals nothing on the other side. You know, okay, so you put a 6 on one side, and you put a 6 on each side. So it's like that's like taking nothing and adding 6, you know, just by putting it there. So a number itself already has the plus. That plus sign, that's what something is. It's what a 1 egg is plus 1 egg. And then that all works too. For negative 1, negative anything, to make negative 1, you put the first, you put a variable like k, like we'll just call it k. 1 plus 1 plus k equals 1. All right, so that k is negative 1. 1 plus 1 plus k equals -1, and that's your definition of k. So you have that little, you have that equation that like let you know, this be true. You have that logical and that logical, whatever you call it, off to the side to have a k, to have -1. And that's, you know, that's a big additional step, because you like, and you put something over to the side and declare that variable, so you get an equation over the side, and it has to fit and be true with your other equation. So, but you make -1 that way. You know, 1 plus 1 plus k equals -1, so k would be -1. Just call it -1. And so, and that's it. You already have addition, subtraction, and for you could just divide stuff by -1. You don't have to multiply it by -1. So you have your division symbol, and you also got 6 divided by -1 is the same thing as -6. And so you just put that there in an equation. You put like 8, you know, in your bracket, and then right next to it, you're not like making 86. You put you put 8, and then you put next to it you put a 6 divided by -1, which you've created, you know, with that other equation. It's very simple. And that would equal 2. You know, so you're able to subtract that way by multiplying by -1, and then it's like you add a negative number. But adding is just putting it there in that place in the bracket. And so the equal sign itself is what makes it crazy. You just get almost like not a lot of symbols. The equal sign is the divided by symbol again. You know, it's like 6 divided by 6 can be equal 6, and you know, to make it and to make it a declarative thing, 6 divided by 6, you know, you usually have the arrow on the divided by symbol, but instead, you know, maybe you put the 2 arrows, so it can be read either way. Or like we'll say 6 equals 3 plus 3, right? So it's like 6 divided by 3 plus 3, or it could be 3 plus 3 divided by 6, and it can be read either way. And that's all it is. That's all your equals thing is. And you don't even have to get in philosophical about it. Something is the same or something. No, because it just fits rules and how you can manipulate stuff on the paper. You don't get to like, what is it, or how, you know, like, what is it? It's the same as. You don't necessarily have to get to that. It'll like, you can extrapolate that or get that, bring that out into, use these symbols to do stuff in the real world. But that's not your actual definition. Your definition is just this stuff on the paper, symbols on the paper, like that. And to make multiplication, of course, you have divided by, and so you have like, okay, for 1 itself, like here's how you even have your numbers. You don't have number theory. You just like, it's like, all it is, it's your brackets, and it's your divided by symbol. It's a divided by symbol. It's in a bracket. And so what is that? Like it could be 0 divided by 0, or not divided by not. And I'll probably call this video 0 divided by 0 equals 1. But it's not, we're not saying divide, put so many eggs in so many baskets and count this, or whatever the hell. You know, it's like symbols on a paper. And you can make it like, I guess, I don't know if the word's extrapolate or whatever the fuck, to like putting eggs in a basket. But it doesn't have to be. It also helps like, okay. And it's so fucking obvious too. And usually you like think, you're divided by symbol. If you had to take an action, like, you know, we're not saying that divided is divided. It's like just a term we call it, but we're not going to go take something, make it into, you know, if it's divided by 2, put it in 2 parts, take one of those and count how much you got there. And that's what divided by is. Like, it's a process. It's not a process. These are just symbols on a paper. And the symbols on a paper will also work to label a process or work like that. But you don't have to worry about it with your number theory. You're like, you know, you have no fucking number theory. We did away with it, okay? And so if you had 2 divided by 0, 2 divided by naught, and it's all in the bracket, so you know it's a naught, because like if it's otherwise, you're gonna, you know, like 0 is the same thing as just not writing something, but you got the bracket there, so you know there's nothing there. On that other side of the divided by symbol. So 2 divided by naught, or 2 divided by 0, that would be inside the bracket. That would be undefined, whatever, it doesn't work in all that. But 0 divided by 0, let's see, there's some mathematical theoreticians, they say that equals 1, which is like how I came up with this. That's how I was able to find this stuff, because I thought that must be that. But Wikipedia, everything I find isn't really good. I look up the terms and it's not really that great. It's supposed to be way simpler. So you take, the 2, and then you have to do what with it, or manipulate it, or whatever. It's not going to work, right? But if it's nothing on top, well, what did I have to do? Nothing to make it do something else. And you can just have it, and you're not doing a process where you're actually taking 6 eggs divided by 3. You take 6 eggs, you put an equal amount in each. You have 3 baskets, put equal amount of eggs in each basket. Then you take 1 basket and you count how many eggs is in it. That's like the definition of divided by in the world. But our symbol divided by isn't that. So our mathematical theory won't even be that stuff, because we don't even need to get to that. And so what we got, just think about it so far. We got, how many symbols do we got? We got the brackets, right? Which is already kind of implied, like everything, because otherwise you'd be looking off the edge of the paper somewhere else. Or if you had some words before it, you'd think that might be part of the equation. Or you gotta have an end of the equation. It's just presumed brackets. So you got brackets, then you have Jesus, right? And then what do you have? You have the divided by symbol, which is directional. You have an arrow, and then you can put another arrow, like, so it can go either way. Be read either way, and that's the equal sign. And then some basic rules, a few rules, and you work with your logic. And your type specimen is like, yes, I'm here with a pencil on this piece of paper. You define it like that. You might go to the physical real world like that. So there's no like deep philosophical fucking anything. And that's it. You got 1. You already have number theory. What is number theory? What is 1? Because I looked at stuff and it's like cuckoo, man. And it'll work for multiplying is divide by. You multiply stuff by that divide by symbol and it'll work out. Like more of those divide by symbols in a bracket. You just count how many there are. And you can replace those, of course, with symbols like 6 for 6 of those. But still, your definition of the numbers is that, like it's like 1s, and then you have a bunch, you can have 6 of them, like in their brackets, and then that might be part of an equation or whatever. Or you can have, and that's it. It's like fucking that. It's like all the fucking way. You already solved the 0 problem, divided by 0, and like and like in the real world, you go, the thing is, like all 0 divided by 0, you also can't multiply by 0 in a certain sense. You could say, hey, take 6 eggs and put them in 0 baskets, and you can't really do that. But you can take 0 eggs and put 0 eggs in each basket. You have 6 baskets, 0 eggs. Put 0 eggs in each basket. Then count how many eggs there are, and that's how you define multiplication in the real world, and it would correlate to symbols. So you go, and so you have divided by for multiply. So these so the actual something times something will be, this many baskets, this many things you put in each basket. It doesn't work both ways. Usually you think 2 times 3 can be 2 eggs and 3 baskets. 3 baskets each with 2 eggs, or 2 baskets each with 3 eggs. But no, in this system it wouldn't be that. It's like one way. And so you also can't say, how would you say? You can multiply 0 by 6, but you can't multiply 6 by 0. Yeah. like that. And so then you could, so you have an equation you could read backwards. That would be, you start out, like, and equations are always within a bracket, the whole equation. So within a, big bracket, it's like 6 divided by 2 equals, wait, no, I'm not getting it right. Okay, 0 times 2 equals 0. And then if you look at it in a mirror, it could be sort of like, 0 divided by 2 equals 0. So you can get, your thing back. Like, there's always the thing, well, why can you multiply by 0 but you can't get it back by division? And this way you can. But only the one way. You put 0 eggs in 2 baskets. Not 2 eggs in 0 baskets. And so you have that. Then you just get into, like, okay, what's the next step? Okay, here we go. What do you call it? Powers. What do you call them? Oh, God, man. Go into the power, like, second power, first power. And you just define the process, like, on the paper, like, 2 to the third power. That's 3, that's 2 times 2 times 2. And there's some simple way to define that. And you can get 2 to the 1/2 power. That would be 2 to the 1 divided by 2 to the 2. 2 to the 1/2 power would be that. Wait. I'm being retarded. 2 to the 1/2 power. No, it'd be like, oh, Jesus Christ, what am I doing? Yeah. 2 to the... I am being retarded. See, I'm getting... It's fuzzy math. It's fuzzy math. I go full retard. I'm all the way retarded, too. Man, like, I don't really want to do symbol. I can do this stuff, like certain things, but I have to write. But you guys know what I mean. Okay, so you get some simple definition for doing your exponents, defining it. And then, okay, check this out. This is it. This is the solution. Now, why is square root of 4? Or, 4 to the 1/2 power. Why is that 2? But it can't be negative 2. Because, like, negative 2 times negative 2 equals 4. And it's just because they define it a certain way. They just say that's what a square root is, so that's what we're doing. But really, like, of the thing that's, like, can be squared and equal 4, well, there's 2 of them. There's, like, 2 and there's negative 2, okay? And so what you do with all this, and how you solve all of this, you got to do a couple steps, but it's still a paper. It's still defined. You're still, your number theory, you're going to be looking at a piece of paper. Because I figured this out last night. Because you do kind of have to take a step. You can't just use what I like to call linear algebra when it's all in a line, but that's not really what it means. But I wish it was called that, like linear math, linear, like you're all in a line. This equals this and that. It's all going, right now it's this long equation in a line. So I like to think of it, even though that's not what that actually means, like a linear algebra. But it'd be cool if it was. But okay, you have square root of -1. It's supposed to be the big mystery number. Oh my God. And no, it's like -1 is already, because like, how do you have -1 eggs in the real world? You bring that out to the real world and you don't got it. You can get, like, but you can play with it on your paper and do stuff and it's good. But you try to bring that to the real world. No, I don't have like -1. You can start defining in certain ways. Yeah, someone owes me an egg or something like that. And it's like an IOU and it's very serious or whatever the fuck. And I'm going to grab an egg and as soon as this paper comes in contact, you got served. So that's how you, like, you put it out and make it similar to real world. I gotta get into dog divided by dog. Let me just do that one thing, because that's a real world thing. Dog divided by dog. There's nothing in the real world that's dog divided by dog, except on paper you can put, like, you have you need 25 pounds of dog food. How much do they fucking eat? They like eat like a motherfucker. Say like they really have to eat. I don't know. 20 pounds of dog food per sled dog per day, right? And I'm out, that's, you need 20 pounds of dog food per sled dog, per sled dog day. And say like I have 2 sled dogs and I was out there for one day, right? Just make it, my brain's mush. And then you can multiply it by that in the other equation, and then the fucking dog divided by dog comes cross that off, and day divided by day. Even though you don't really go divide a day, and in the real world, but it works that way. And that's why even the divided by, you'd have a different name for it, that symbol, because sometimes you're not actually dividing, because that's not quite what you're doing. You're crossing it out, like when it's dog divided by dog. It's not like dividing. Now, okay, for the exponents for the square root of -1i is not like some big spooky thing anymore, because it's already -1 is. Like, that's the big one. We had to create a whole variable. Oh yeah, that's right, because that's one additional thing we had to do for our math is we got our symbols, we got the brackets, we got the fucking all we had, right? We had brackets, fucking the divided by symbol, with its arrow direction, and then we do one with both arrows go both ways, so that'll be equal sign. And then we had to do -1, like I was saying, it's k. 1 plus 1 plus k equals 1. And that's our -1. And you can multiply things, divided by to multiply. Or you can just divide by -1 to make a negative number. And you have subtraction, that's all like, just putting it there. Because that's what addition is. And so it's just like that. And so, but it's already that thing, that the k or the -1, you can't bring that out into the world. It gets spooky, weird. Oh, I have -1 cans of beans. And it's like, you can't do that in the real world. You're manipulating this equation, and if you get it to come out, and it's like a positive number, or 0 cans of beans, you can talk about it in the real world. There's 0 cans on the table, or there's 3, or something like that. And so square root of -1, all that stuff is just like, you don't have it out in the real world, in some way. Well, that's all our definitions are just symbols on paper anyway. And the way we do this, we're going to separate the negativity from the rest of the number by taking the absolute value of every number. So if I have -6 or whatever, I'm going to say the absolute value of -6 is 6. It's like the distance from 0 is 6. And the way I define it, because there's not a algebraic process to get the absolute value, I think. I would expect there isn't. But what you do, you write your graph on a piece of paper with your 2 axes, x and y. The x is the negative numbers to the positive numbers, and the y is like the I, like negative I down below and positive I up above. And it's a graph, goes around a circle, and you can have any points on there. Like I plus 1, that that's when you use square root of 2, absolute value. That's how far it is from 0. You guys know I should be showing that, but and so that's your definition of what an absolute value is. You're going to the paper, you never have to get, and it doesn't get mysterious. It's not weird, and it doesn't get, if you're just doing that with mathematics, linear, what I call linear algebra, like writing symbols on paper, gets weird. But this is the better symbol, to look, and it's actually the definition of what the absolute value is. There might not be another way to do it in the equation form, to extract an absolute value like that. Say that's what that is. So you have absolute value like that, and you can define it simply, and you got this other piece of paper with a fucking ruler on it, and you just count the how fucking distance from the 0. So you have absolute value, and then you have that number divided by its absolute value. And so that number divided by its absolute value, and that's way better, to write these what do they call them? Not magical numbers, the imaginary numbers. The imaginary numbers, or compound imaginary numbers, You got like 1 plus I, like 1 is the so-called real portion, and the I, or 1 I is like the iota is the imaginary, so-called. And but that gets like weird shit, and then you had to go up, and it's like, and then that's still like the square root of 2 absolute value. And it's way better if you just like wind it around like a clock, like the the negativity. You wind it around, right? And so what I do, instead of like taking -1 and starting to get I from that, like -1 to the 1/2 is I, -1 to the 2 to squared is 1, right? But it's also -1 to the 0 is 1, like that. So instead I'm going to have -1 times -1 in a bracket, and then the exponent for there, that's one additional symbol we have to make. So we have to take one more step, but then it becomes all simple and defined, and like it's like right in front of you. Like you get the -1 to the 1/2 times -1 to the 1/2. But that 1/2, you like make a line up there, and like it goes to outside that. It's like that's 1/2. It goes inside that bracket into each of those -1s. So -1 to the 1/2 times -1 to the 1/2 is -1, because the square root of -1 times the square root of -1, which is equals -1. That's I times I. But if you took those -1 times -1, that's 1, and then you put that to the 1/2, that'd be square root of 1. And this is the way, and you get into define which are you doing first. You inside the bracket, outside the bracket, whatever, and you can always rewind it back to like fucking, to the 0th power or to the 1 power. So that thing, that -1 times -1 in a bracket with the exponent coming out and showing, it's got a shared exponent. So that -1 to the -1, and those 2 lines that go up from each -1 to that. To that 1, it would be -1 to 1 times -1 to the 1, which would be 1. Or, equals 1. The same thing as like -1 to 0. And it gets so you can define all this stuff. All of it. And that's all I've gotten so far. And of course they say, like, you go look it up and go, oh man, negative. So what's 0 to the power of 0? And they go, oh man, that's always 1. Almost those mathematicians will do that. But I don't know, 0 divided by 0, and they're not defining it. Like there's they get into mathematical theory or something, and there's no theory here. This is like it's just symbols on the paper, and you can talk about how you manipulate them. And you get your type specimen or whatever, which is your piece of paper with your pencil and your eraser and your process and the brackets and how you manipulate it. And it's very simple. And you've got all the problems of square root of -1, and it just winds around. It's like it goes from, so that -1 times -1 with that whole fucking thing with exponent, you write outside, but it's like going on to the inside of each one. 1 and 0 would be the same. And you might even make a special symbol of that. So like 1 and 0, and it just winds around like a clock. And that thing to the 1/2 is like that would be -1. And I don't know if there's not like other. Well, there's no other algebraic. See, you hit the limit of algebra. Like you think, oh man, it's so weird with I don't know, Euler's formula. I can't get the fucking stuff and pi and they keep going with a fucking sine and cosine. They don't like do other shit and say what you can manipulate and whatever the fuck, or try graphing anything. So I'm not really sure about that. But this thing is all fucking defined, and you got everything. You even got absolute value in your definition. It's like you made a graph and you looked at it. and you can and you just you set the distance from that 0, and you can define it by, like, you got this other piece of paper that has like a ruler, and you like put that on there, and you try to get that really accurate, and you just do that. And that also fits your mathematical stuff, though, when you manipulate. Like, your ruler will find I plus 1. The absolute value of that is like square root of 2. And your ruler will find that. But, and you can tell, in your math you can get exact with it. Will be times. And that would be like, so I plus 1, instead of like writing I plus 1, instead of a complex number, whatever the fuck they call it, you have an absolute value number. So that'd be, instead of writing I plus 1 or 1 plus I, the way they usually write a complex number, or this imaginary component is so-called real component, you write it square root of negative 1 times, which is like divided by in symbology, like whatever, or maybe the other way around, like, but divided by it would end up being that thing that I call 1, that 1, negative 1 times 1, negative 1, that thing to the 1/4 would be I, so it would be like that thing to the 1/8, right? And it gets real easier to think. And you're like, otherwise you're looking at this fucking stuff. It's like doing a Rubik's Cube. You can kind of think about it, but then when they start writing out the symbols on a piece of paper, it doesn't work. And you're like, so it's it. And you got everything defined. Like even number theory, it's just the divided by symbol, like in a bracket, within the two brackets, with nothing there. So it'd be like not divided by not. And it's not really divided by. It can work as divided by in the real world. And that's 1. It all fucking works too. And gets all the way in. Okay, so yeah, you don't get past for algebra. You don't get past. It doesn't keep going crazy weird. You got square root of negative 1 and all the doodads, and they all fit algebraically, but you can't do more. There's not some other weird thing in that graphing where you graph in 2 dimensions. You can't bring something into 3 dimensions and also do it with what I call linear algebra. I wish there was a cool name like that, like your equation in a line, even though that's not the way what they use that term for. I like to use that term, like it's your linear algebra.